Problem 35. In the given figure, three charged particles lie on an x-axis. Particle 1 and 2 are fixed in place. Particle 3 is free to move. But the net electrostatic force on it from particles 1 and 2 happens to be 0. If 2L23 equal to L12, what is the ratio Q1 over Q2? So in this question, we are going to find the value of Q1 over Q2. So this value we have to find. But also they gave some information. So if you have to see this diagram. You have particle 1 and 2, which are exactly fixed on x-axis, and third particle is also on x-axis, but the third particle has the nature to free to move. And also they mentioned the particle 1 and 2 on third is equal to 0. That means the interaction, the force, the electrostatic force of charge 1 on 3 and the electrostatic force of 2 on 3 should be equal to 0. For example, you can see here we have three charges, right? So particle 1, particle 2 and particle 3, and these three charges are exactly on the same x-axis. So they said this is first particle, second particle, third particle. What they said, the distance between 1 and 2 is L12 and the distance between 2 and 3 is L23. And what they said here, you have to read this line very carefully. So the net electrostatic force on it from particle 1 and 2 happens to be 0. That means the particle 1 on 3, the particle 2 on 3 is equal to 0. That means the electrostatic force interaction of 1 on 3 and 2 on 3 is equal to 0. That means how you will get the diagram? When the first particle interact with the third particle, maybe you will get the diagram like this. For example, let's we take this is positive. Let's we take this is positive, this is negative. Okay, the third particle, let's we assume it's positive. So you can see the first particle here is positive because they did not mention anything. I'm just giving some the examples. Okay, so how the interaction of 1 on 3 and 2 on 3 will be equal to 0. If you see the positive interact with the positive, what will happen? It will repel. So that means this is F13, and the particle 2 and 3 get attractive because it is negative, this is positive, so this is F23. So then only you will get, you can see the arrow mark, right hand side and left hand side you have the same magnitude. So by that what will happen, the net electrostatic force of 1 and 2 on 3 should be equal to 0. Clear? But in the question they did not mention positive, negative, positive. This is just an explanation purpose, I gave this. So when you will get the net electrostatic force which is equal to 0, you have to get the diagram like this. That means if positive, first particle is positive, third particle is positive, let's take, what will happen? Positive interact with this positive, it will repel. And second is negative, negative interact with positive, attract. So you can see this arrow mark, F13 right hand side, F23 left hand side, and it's equal in magnitude. By the time what you will get 0, right? The net electrostatic will be equal to 0. Now what we have to do, I have to consider this diagram. So what I'm going to do, I'm going to take F13 equal to F23, or you can take F23 which is equal to F13, both are same. Now I'm going to write the Coulomb's law for this case and this case. So what's Coulomb's law exactly says? F13. Am I right? So how I can write? K magnitude of the first charge, magnitude of the third charge, right? Divided by what's the distance between 1 and 3? If you see the distance between 1 and 3, which is L12 plus L23. Am I right or not? Because the distance matter. When you apply the Coulomb's law, you need the distance between the two charges. That means here, what are the two charges? The two charge particle 1 and particle 3. So what's the distance between particle 1 and 3? You can see L12 plus L23. It's the distance. So I have to write L12 plus L23, and it should be square, right? Which is equal to, I have to write the Coulomb's law for this case, between charge 2 and 3. That means the particle 2 and 3. K magnitude of the second charge, magnitude of the third charge divided by, now we have to see what's the distance between 2 and 3, L23 only, right? So I can write L23 square. Clear? Now you can see we can cancel some term because K cancel left hand side and right hand side. Likewise, we can cancel Q3 and Q3. And now what I'm going to do, because they said we have to find Q1 over Q2, right? So I'm going to separate charge one side. I'm going to separate the distance one side. So that means I'm going to bring these charge to the left hand side of the denominator. So how I will get Q1 over Q2, and then I can bring this one to the right hand side of the numerator. So L12 plus L23 whole square divided by L23 square. Clear? And now what we have to do, we have to see the given first. What is given? Because they just gave something about this distance, am I right? 2L23 which is equal to L12. So I can write this given because we have to substitute this here for simplifying this problem. Okay, so we can make the steps easy. So what they said, 2, it's given in the question, 2L23 which is equal to L12. Am I right? So now I am going to substitute. So where we have L23 or we have L12, so we have this. Am I right? So that means L12 which is equal to 2 times of L23. So I can substitute the value here. So what you will get, Q1 over Q2 which is equal to 2L23. Am I right? Plus already L23 is there. So 2L23 the whole square divided by L23 square, right? So now if you simplify, 2L23 plus 1L23 which is 3L23 the whole square divided by L23 square. So now you can see this L23 square we can cancel here. So we can cancel this L23, but you have to use this square here. So what you'll get, only you will have 3 square. Am I right? Because this square is common for both 3 as well as L23. So we will cancel only L23 square top and bottom. So what you have in the right hand side now, the remaining term is only 3 square. So what you will get here, the answer here is Q1 over Q2 which is equal to 3 square, which is 9. But we have to give the sign. Why? Because sign matters, right? So here, if you see the diagram, Q1 and Q2 must be opposite nature. Am I right? So you can go back to the diagram. Q1 and Q2 must be opposite. That means that's the reason I put positive and negative here. Then only it have the repulsive force and attractive force, something you will get, you can achieve this situation, right? So that means here Q1 and Q2 must be opposite nature. So Q1 should be positive, Q2 should be negative. So we have to substitute the value here. Q1 is positive and Q2 is negative, right? So what you will get, Q1 over Q2 which is equal to -9, right? So this is the answer for this question. Thank you.